So good afternoon today. Today we are going to talk about SSD cache with LSI NYTRO MegaRAID product, and this is a short presentation because we will focus only how to quickly prove advantage of SSD cache, because SSD cache doesn't help in every benchmark pattern. It helps in the most problematic benchmark pattern. So the SSD cache is helping you to solve so-called real-life problems or I/O problems, databases problems. It will not help you to solve sequential problems, because in most cases sequential performance is great and there is no need to improve it. All the marketing material publications, they publish mostly sequential performance, because the sequential performance numbers, figures are the most impressive, and the real life figures, so the I/O performance figures, mostly are not, because this depends on the speed of the hard disk. And here SSD cache is great functionality to fix this problem. So for today I have prepared a short discussion about the random and the sequential performance pattern. I will show it in IOmeter. Then we are going to run a short sequential and so-called real-life test, which is defined as 60% random, 65% reads, of course rest are writes, and with small block, 8K block, 8 kilobyte block is a small block. Then next one is SQLIO test, which is made by Microsoft. The IOmeter test was originally developed by community and Intel. Now is actually Intel, now it's open source. Good, so let us start. Here I will switch to my workstation, and I have already DSS with two small logical volumes. I have one very small logical volume, which is 2 gigabyte only. Don't be surprised, we will just explain soon why so small. And then just 100 gig. Mostly we will use these very small, because we have no time and we need to do it quickly. So in webinars you will not try to wait 1 hour until you will see really good results, how the hot data algorithm works in SSD cache. So this is why for the fast results we have this 2 gigabyte size only. Good, so I was exporting these logical units via iSCSI target, just a single target. Both logical units are here. Of course, in the practical installations, mostly you will have a separate target for every logical volume, but it works. So this is faster to set up, so I was making this way. Of course, iSCSI initiator is already connected, and in properties, okay, you see that the session is started, and when I go to disk management, you see that both disks are just formatted. Okay, I will remove the format, because on IOmeter I will run the test on raw disk without the format, and on SQLIO I will do it with format. So let us remove I could do it also with format on IOmeter, then I will need to wait until the test file is created or create mine test file. But the results are very, very similar. So now I have a 2 row disk not formatted available, and let us start IOmeter. I was installing IOmeter already. Okay, so IOmeter was started before, so I need to make sure it's really stopped. Great, and let us go to the MegaRAID. I'm not going to explain how to install MegaRAID today. We will have another session with installing. Today we are really focusing how to get a fast proof that SSD cache, in this case I have a NYTRO product, means the SSD cache is already on the PCB, on the RAID controller board. Advantage of this solution is that the LSI ship really good quality SSD, proved quality SSD, because when you're using just a Cascade product, you can select your SSD and then you have a chance to select not good quality and you may have some problems. Anyway, if you use Cascade, so we are recommending good quality product. For example, Intel 3700 series. It's quite recommended because it has a very good reliability. You can endurance is 10 times capacity per day, 5 years long, and the performance is also good. But in case of NYTRO product, you have already SSD on the board. So in our case, I have a small SSDs. I will show you here. There are 2 SSDs which are configured as a RAID 1. So RAID 1 means I will be able to use a read and write cache. And my RAID array is RAID 5, and it consists of 12 drives. So my RAID array is already quite fast. I will have even much better results that I'm going to show today with a smaller number of disks. Let's say when you will have a 5 disk or 6 disk only, then the Cascade will more drastically improve the performance. My RAID array consists of 12 drives, so my I/O performance is already considered good. Okay, and then also we will test this, so we will see the result. Okay, so let me see the read cache. The NYTRO cache here is still showing, but I was just now pressing this refresh button, and then you see it's disabled now. So I have a pure RAID 5 RAID array, which is consists of 7200 RPM SAS drives. Okay, so let us go to IOmeter, and okay, my RAID array, I have 2 physical disks. So the first one is 2 gig, second one is this 100 gig. I can take the 100 gig first, for example, and then I can select all workers to work on this. I can try with, let's say, quite many, 32 outstanding I/O, and I can try to make a so-called sequential pattern. So in sequential pattern, the minimum block size is 64K. Of course, pattern is sequential, and then I'm using whether write or read. Okay, let us use the write first. That's my pattern. I was selecting the host, means when I add, all the workers get the same pattern. In the result display, okay, I can just click here, start the test. Here I can save results, but I don't need the results, so the test is starting right now. I have 10 gigabit Ethernet connection between my data storage server and this Windows client. So you see, I'm writing now 12 hard disk, 10 gigabit Ethernet, so my performance on the sequential without cascade, of course, I'm seeing here something like 12,600 I/O with 64K. That's giving me 790 megabyte per second, right? So in sequential way, my RAID array is quite fast, and I can be proud to put such a number into the marketing material, and because I can say, okay, I'm reaching almost 800 megabyte per second on my iSCSI SanDisk, right? And I'm proud about it, right? But what happened, let's say, when I'm interested in reads? Maybe reads are better or worse. Let us see. So I will remove this and change to reads. Okay, let us change, add, and start the test one more time. Okay, so the results are very, very similar. You see, we are also reaching this kind of 700, 800 megabyte per second number. So this is great, but now you may ask, why I have so great speed, why I need a cascade. So let us start to look where the problem is. What happened when I switch to 8K block, and what happened when I switch to random, and what happened when I switch to mixed. So 65% read and 35 writes. That's about, of course you can use a different, some people use, let's say, 50% random, 50 sequential, and 50% read and write, and that's so-called 50-50 test. But you know, recently the community called this kind of pattern as a real life test, and the 8K block, in many cases 8K block is used for transferring. I was reading that the 8K block is used for log in the Microsoft SQL, and the 64-bit 64K for data. But anyway, we can test with 8, and we can test also with 64. But okay, I was redefining my pattern, and before I was reaching 800 megabyte per second. Let's see what happened now. Okay. Wow, that's difference. Before I was touching 800 megabyte per second, and now I'm touching maybe 10 megabyte per second. So now it's exactly 8.7 megabyte per second, and it's still declining. So, and instead of 12,000 I/O, I see here 1,000 I/O, 8.5 megabyte per second. Wow, that's difference. And this is normal, because in random performance pattern, in this pattern which we defined here, we are reading and writing at the same time, and we reading the data from the different part of disk. Means the disk head need to move every I/O, and here the average access time is a very important factor. And because we are reading and writing, because we have some vibration, because there is so many disks working here together, so this is why the performance of such a very fast RAID array is actually not so great. Is in this case only 8 megabyte per second. 8 megabyte in if you compare to 800, that's 100 times slower, almost 100 times slower. So this is the point where the SSDs are great, because they don't need to move the the accessing data from the next sector or very near, and accessing data from the very last sector is exactly the same. So let us see what happened when I will enable the SSD cache now. So I'm changing to MegaRAID and go to properties, enable Nitro Cache. Yes. So it is not enabled at once, but when I click on refresh button here, okay, now I see my Nitro Cache is for read and write, because I was defining RAID 1 for my SSD drives. Okay, on the SAS drives I have a RAID 5, and then my cache is consisting of the also RAID array, RAID 1, so mirror. Okay, I didn't change the pattern. I was but I was using in this case this bigger disk, and this bigger disk, when I start the test, I may expect some improvement, and I see it is already going to improve, but I will need to wait a quite long time until my hot data pattern will learn and which data need to be cached and so on, because there is a big storage. This is why, to see the quick results, I was preparing this small disk. Okay, so now I'm using the small disk, and when I start the test on the small disk, I will see the performance growing much faster already. So here is I/O per second, and here is megabyte per second. So maybe so you see, having a very small disk, I'm able to show how the hot data caching algorithm is working. On the bigger size disk, this process will take few hours. But once controller learn the hot data, then everything will stabilize. Then probably 80, 90, or even more % of your access will be very fast, so you will have a great I/O. So you see, from the range of 1000 we are now in the range of 10,000. Of course it will grow maybe to 12 or 13,000. So that's the way how you can quickly show your customer that the cache really works with the so-called real life pattern. We will be not able to prove advantage on the sequential pattern, because in this case on sequential I will have even lower I/O than my RAID array, because here on the front I have just a RAID 1 of the SSD, so the speed of single SSD is a bottleneck here on the sequential access. If I would like to have also good sequential access on my SSD cache, then I will need to decide for 4 disks and make a RAID 10 of them, so striping over 2 mirrors. Then I will have already comparable sequential performance with my SAS RAID array. Okay, so I think we are okay. We don't need to wait for, let's say, until it will reach maybe 13 or 14,000 I/O per second. This is already convincing enough. Let us and this is showing good how it works, but a very interesting test is also database test made by Microsoft. So I have here so-called SQLIO. You can download or search, just Google for SQLIO, benchmark patterns and so on. You will find plenty blogs or discussions about how this test is working. I will not really talk about theory about this test. We will just start the test. I have prepared a small Excel chart, because before our webinar I was already getting the results, and we will start to test them. Some of them, not all of them, some of them I will just use this which I was having already. Okay, so that's some material which will help me. So the very first step, we need to create the test file for the SQLIO, and here there is a line, create test file, that's SQLIO. Parameter K means read or write, so I will be writing. S is how many seconds. F can be sequential or random. O, it is how many outstanding I/O. B is a block size in kilobyte, and the F is a file with the parameters. So after installing your SQL, okay, I will go to the drive C. Okay, after installing my SQLIO, I have here a param file. So when I edit here, I can put the file name, and here there is a size in megabyte. So on the C, that's my local Windows drive, I put 2000 megabyte, and on my drive D, which will be my very small 2 gigabyte iSCSI drive, I will also put 2000 megabyte file. Okay, so I have this file, so this file is saved. Please note that you can't have any here file or even spaces, so you must delete everything exactly. You must have only the pure lines saved. Okay, that's my param file, and now I can issue the command for creating that's the command, SQLIO. The car parameter is write or read, so in this case of course I'm writing. 5 seconds, sequential, 4 outstanding I/O, 64-bit K, and I'm using this file parameter.txt. So enter this. It doesn't work because I didn't format my hard disks, my iSCSI disks yet. So let us create a volume. Okay, so actually I will use only the first disk, so this is enough when I format only this one. And there is one small thing, when I will still try to find this right now, so it was already creating the files. Let us see. I don't know exactly, because in most cases I was having here kind of error, because when the disk is just new created, you must make sure in properties that in the security you can edit, and then for the, let's say for everyone, you select the modify, that you can access, you know, the file in the root directory. Okay, so apply. Please do it, because otherwise you may have a problem with testing. Okay, so let us see. On the C we have this drive, a test file already, and on the D it was created as well. I can maybe just repeat the process. So you see, using specified file, it's 2000 megabyte for the C test, and same for the D test file, and that was the speed. One more time, 8000 I/O, 500 megabyte per second. So we have the test files, and now of course we are curious what happened what is the difference in performance between the local drive and iSCSI drive and the drive which is with or without Cache. So on the beginning I will disable Nitro Cache. Okay, I confirm. Yes. So sometimes there are data that you need to wait a little, maybe just refresh and see. It was no much data, so I was not need to wait. Okay, it is disabled already, and now I will start some testing. So my testing will be, hardware caching. This parameter ls means will also show us the latency. This one means writing. This one means 8 threads. This one is 10 seconds. 8 outstanding I/O, random, and block size 8K. And let us see. I will start with the drive on the local drive. So what I'm getting here, okay, on my local drive, maybe I repeat it, you see I was getting 832 I/O per second, what is giving me with 8K block 6.5 megabyte per second. Repeat one more time. So now it's worse, 500, so 499 I/O, and it is giving 3.9 megabyte per second. Okay, looks like that this value about 400 is more consistent, because when you repeat this test few times, you must get the average. Okay, so it's even going down. So probably I will use the test results which are just coming. Okay, so 476 and 3.7. 476 and 3.7. Okay, that's the current result. And let us try with a 64K block. So I'm do the same with the 64K block. $64K block, of course, the megabyte per second will be much better, and I/O per second supposed to be a bit lower in such case. Sorry, I/O per second should be lower and the megabyte per second should be higher. So I'm test few times. 10 seconds is already enough. Maybe we should give maybe 30 or 90. Some people giving even 90 seconds, then having more average results. So 461 and 28. 461 and 28.8, something like this. So maybe 29. Okay, doesn't matter. Okay, so that's our results from my local drive. Now I'm switching with the same test. So first with the 8K block, and I'm switching to D, so to my iSCSI drive without cache. Normally, when you will use SQLIO with bigger drive, you will also have the similar results like in the smaller drive. When the test file is bigger, then you will need to wait for the better results of the Cascade or Nitro Cache a bit longer. So here I'm seeing 1657 or 1658. Okay, so 1658, and megabyte per second was just 13. Okay, so 13. You see the results are very similar to the test I was doing few minutes before. Okay, and let us try the same with the 64K. So let us repeat. I will repeat it with 64K. So with 64K, I'm about the same, almost the same I/O, but of course better results on the megabyte per second. So here I have 1504 and 94, 1504 and about 94. Okay, so that was the test without Nitro cache. Now I need to enable the cache. Okay, refresh to make sure that yes, I have it. Then let us start. The very first test we want to start is with with a 8K. With cache, probably the first results will be not the best because the algorithm is about hot data, so probably you need to run this test few times until you see the stable result. It looks like it's stabilizing on something like almost 13,000 I/O here and about 100 megabytes per second. So I have the results 12,620. Okay, 12,620, and in case of 98.6. Okay, 98.6. Whoa, that when I'm calculating the percentage, so I see here 7.6 times better in case of I/O, and 7.6 times better in case of megabyte per second. This number will be even better, or maybe 10 times better, when my RAID array will consist not from 12 drives but maybe from 6 or 5 drives. Then the cache performance is stable, but the RAID performance will be dropping. So with the smaller number of drives in RAID, this advantage is even more drastic, more better. Now let us see what happened with the 64K. So I'm switching here, and then I will test with 64K. Okay, but now the MegaRAID was still with cache on. Okay, so I'm testing 64K with the cache. Now you see the I/O is a bit lower, is 6,484, but the megabyte is already quite nice. It was 405, and the second time the numbers are almost the same. So I take 6,401, 6,401, and let's say 400. It was 400, yes, exactly. megabyte per second, and we can do the same, but let us switch off the cache. Okay, so when I'm refreshing, you see it's not switching off at once because it was some data inside. Okay, so let us run the 64K on iSCSI but no cache. Okay, so I have a 1635 and 102. 1635 and 102, I guess. Yes, exactly. Okay, so in this case we have a almost 4 times better performance on the 64K, and we have 7.6 times better performance on 8K. Okay, and the same thing happened with the read, and the read, you see that's something like 17 times better here on the 8K on reading, and then 18 times better. It was also 18 times, almost 18 times better on the IO per second and the megabyte per second. Let us try it. So I will switch now to the read test. So it is very easy to switch. We just need to go to this parameter and just change to R like read, and let's say 8. I was taking 10 seconds because of the webinar. I don't want to waste your time, and if in 10 seconds I'm getting already quite of stable results, then it's okay. So you see now I'm getting 1136 and almost 9, so 1136 1136 and yeah 9, it's the same result. And now 64, so let us repeat this for 64. Okay, it's 1073 and 67. Okay, good. That's our result with no cache. We can repeat results with cache. So now I go to the RAID controller, enable, refresh. Okay, now cache is up and running. So the very first results we can make on 8K block, and because of cache probably I will need to repeat twice or 3 times until the result is stable enough. I'm testing now. Okay, we need to wait. We have a very similar effect like it was in IOmeter. Starting from over 1,000, over almost 3,000, 11,000, and now you see I'm reaching 20,000 or even more. But it was taking not a long time. Okay, and now my results are stabilizing on the 20,600. Okay, I can take 2339 and 159. Okay, that's my results with 8K, and we can make the very last results with 64K. Okay, looks like it's almost stable, so 10,963. 10,963, and very similar as the last time, and here is a 685. Okay, so we managed to see all the test results live, and as you see, in case of reading, that's 1000% means 10 times better on 64K, almost 18 times better on the 8K, with fast RAID array. Our RAID array is 12 SAS 7200 RPM drives, and here you see 7.6 times better on the 8K block, and then 4 times better on the 64K block on writes. So that's the write and that's the read table. Okay, I hope that my presentation was convincing, and you can use it to convince your customer for the very great cache solution, which is improving performance in a dramatical way, and your investment is not so how to say, in budget, because you don't need to buy so many SSD drives. You just need to buy a RAID controller. This is elegant because it's at a transferable for the operating system, and thanks this you can compete with the high-end storage vendors, just using commodity hardware plus the Nitro Cache or Cascade and from LSI and the DSS, and you have a high performance storage solution. I'm ready to answer questions. If you have any, just type in the chat. If there is no question, everything is clean, then I would like to introduce that we are planning one more webinar with the theory. So we will explain the algorithm, the hot cache, the hot data, how it works. Okay, I see some question. Do you advise to use Cascade for Hyper-V server with local RAID 5? Okay, the local RAID 5 consists of 8 SAS drives. Yes, because everything doesn't matter if you have a SAS 10K or SAS 15K, then SSD cache is always better in case of I/O. So that's you will have improvements every time. Next question. Hi Janusz, I was wondering whether you would done any performance tests with the virtual machines. Oh, with virtual machines you can expect the same or similar improvements when I was having with the physical machine. So for any applications which is not a backup or streaming video or this kind of stuff, you will have improvement, everything what is near to real life, or a real life pattern direction, then you will have improvement with the SSD cache always. But if this your server is a backup server, or your server is a video post-production or this kind of stuff, when there is almost no random I/O, then in such case, of course, that will be a wrong decision to putting SSD, let's say, with RAID 1. You could put SSD cache, but you need to have in such case RAID 10 when you will have a better sequential performance, because in my case, when I will do the sequential performance with the cache, I will have a lower result than the pure RAID array. And don't be surprised, because I have a 12 drives which has no problem with sequential pattern, and I have just a RAID 1, so like a single drive SSD, which I will not reach the 800 megabyte per second when I was reaching with RAID 5 RAID array. With this case, I will have a bottleneck about maybe 400-500 megabyte per second. And this is still very fast for the single drive, but SSD are faster not only in the random pattern, but they are also faster on the sequential pattern. But you cannot compare one disk to 12 disk, right? So that's the difference. I hope all is now clean, and you can use this material for your customer to convince. And I'm wishing you happy selling. Okay, then one more question. Fantastic, thank you. Also with the LSI controller, do the SSD have to be in RAID 1 to enable write caching? Oh yes, because if you put RAID 0 or just a single drive, please use read caching only, because in case of failure, when you will have a failure on the SSD, you may lose your data. So for the write caching, you must have the redundancy. So RAID 1 or RAID 10 must be installed if you are using a write cache. In case of cluster, you maybe, because the cluster is already mirrored, so you may have such a solution that you have a single drive or maybe RAID 0 on the SSD cache, especially when the cache is a good quality or just a NYTRO cache. But if you have a single server, then of course there is a big danger of putting this as a RAID 0 or just a single drive. NYTRO don't have single drive, then they start with 2, but you can put RAID 0. In such case, if there is a failure, then there is a danger of losing your data. Because RAID 0, you know how RAID 0 works. One drive has a problem, then all your data has a problem. There is no redundancy at all. Okay, so thank you very much for the detailed information. It was a win to achieve this information. Okay, great. Is the cache for all RAID sets or for one to select? I select. So in the NYTRO or MegaRAID GUI, you may have one NYTRO cache, and you can assign part to one array, another part to another array. But how to do it in the detail, I will note that it was such a question, and maybe we will show on the next webinar, when we will talk about web theory, and we'll talk about how to configure, how to set up, and what will be the best practices here, right? But even if you have a default, then I was just having all defaults here, and then I was getting already, as you have seen, great performance. Next. Okay, that makes sense. Thanks a lot. Okay, great. Have a great day. Okay, so guys, thank you very much for your time, and then I'm inviting you soon for the next webinar, when we will talk about theory, and we will also show the configuration details. So thank you very much, and bye bye.